Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today, our special guest is Mark Berger. Mark is the Vice President of Product and Program Management at Fluence. And if you haven't heard of Fluence yet, let me tell you a little bit about Fluence because I just looked it up in the dictionary and there's three different definitions that I have right here. One is it's informal British and it's a mysterious, magical, or hypnotic power. And an example of using this in a sentence is you've put the fluence on me, haven't you? So let's see if Mark puts the fluence on us. Another definition is the number of radiant energy particles emitted from the incident on a surface in a given period of time divided by the area of that surface. That sounds a little bit more scientific. And then my third definition here is it's the best energy storage system company. That's ESS. Which one of those definitions, Mark? What do you think?
Well, I think we're probably a combination of all three of those, but it's good to see that we're at least on there for the energy storage company. So I'll go with that one.
Okay, that's probably a really good one. But hopefully by the end of this podcast, you're going to put the fluence on me with your mysterious, magical, and hypnotic powers that you get through Fluence. One of the things that makes Fluence stand out when I'm looking at the Fluence products is you have this really neat looking cube. So with the cube shape and all that, and I think you also have cuboid, which would be like kind of a rectangular cube or container shape, something like that. Which one is more popular these days?
Well, the cube that you can readily find when you do look up Fluence is our current product that we're offering out there. And it really was the product that had exponential growth for Fluence here and the industry as a whole. So when we first started out, back in 2018, 2019, they were putting these large blocks out there. And what we found was that a more modular solution would be most advantageous for the style and the use cases of our customers. So the Cube was born and we really saw tremendous growth with the Cube. Now in the industry, what we are seeing is that there's a lot more emphasis on density as these projects get much, much larger than they had in the past when we were just talking about a few, tens of megawatts to now where we're talking about hundreds of megawatts, that we're seeing that density is becoming a big place. You're going to see larger form factor enclosures and higher cell capacities as well. And us and, the market as a whole is going to try to put as much energy into those enclosures as possible. And that's really driven for two things: that we're getting closer to urban areas, and then we also are seeing that the restriction of the land area available where the interconnect is possible. So you get a high level of interconnect and a very small area to put it on, you need to go dense.
Great. Yeah. Yeah. And the cubes just look really neat to me. It kind of reminds me of like an Apple type of a thing, where it just looks really cool. And so Fluence also has a relationship with Siemens, which is one of those big, giant multinational companies. And then you have, I guess, hardware and software. So maybe you could talk a little bit about that. Like, what's the relationship to Siemens? Like, you have your own stock. And then also, do you use Siemens parts? Do you use non-Siemens parts? How does all that work?
Sure. So Fluence was originally founded as a joint venture between AES Corporation and Siemens. And they provided a lot of support for us when we were just getting started back in 2018, 2019. In the early stages of that joint venture, really Siemens, we were able to leverage a core competency and a global reach that they had to really open up doors to customers for us and provide those introductions. And then on the AES side, they really helped deliver something into our core culture here, which is to be customer centric. But as far as like the actual elements that go into our product, we don't necessarily use Siemens components. We use the components that we find to be best for the application in the market. So we're not restricted or really limited to what we can use. So we'll go out there and find the best that meets the needs.
So it's still, I guess, a joint venture. How does that work? Does Siemens own part of Fluence? Does AES own part of Fluence?
Yeah, certainly. So we went public just before I joined back in 2022. So we went public back in October of 2021. And Siemens and AES still own some stock here in Fluence. And It's still a joint venture from that aspect that they have stock in there. But yeah, we're standing on our own at this point.
So since I have a few shares of Fluence stock, does that mean I'm part of this joint venture, me and Siemens and AES?
I think for your Fluent stock that it would be separate. They own their percentage of stock and you own yours. And we got to help both of y'all realize the value.
I guess I won't go out there bragging about my joint venture with Siemens and AES. Maybe you could tell me too a little bit about AES.
Yeah, so AES is really a great partner that we have here. As I said earlier, they helped us learn what our customers would need, what do they care about, and put into our culture here at Fluence to be customer centric. And we're hearing that across the globe from all of our customers that they really do enjoy that we don't just drop a product on site and then walk away, that we're in there from the beginning, helping them figure out like navigating the permitting and figuring out how they would actually engage this asset into the market to monetize it for themselves. But then also we're there for their operation and their serviceability as well as they go throughout the life. So that would be one of the biggest aspects that AES helped us out with here. And they remain today to be one great customer of ours.
Okay, so what is the difference between Fluence and AES? So you said AES is a customer, and also what does AES stand for?
AES stands for Applied Energy Services, and they're an energy consulting company that mostly operates in the Americas on both North and South America. So they will take our product and they will develop a project out with that and be able to deliver it either to their customers or they'll operate it themselves into the energy markets.
So they're more like the company that gets it going on the ground, I guess.
That's correct. Yes.
And so Fluence does not do that. Is that correct?
No, we don't. So we sell the product and we support the product. So we have multitude of different types of customers. We have either developers that are going to be, taking our product and getting it onto the ground and installed and commissioned, and then they will sell that off. Or we have actual operators that will purchase the equipment and then they will operate the asset for its complete life cycle. So we have various different customers, but we don't play in the energy market and deliver the energy in. We are a product company that is developing those products to facilitate that energy transition.
Yeah, I recently read an article about 2.2 gigawatt hours of batteries, something to do with Fluence.
Yeah, that's correct. So Fluence is actually going to be one of the first to deliver a domestic manufactured product that meets the Inflation Reduction Act's standards for qualifying for manufactured in the US. And we are looking at that deal with Excelsior to deliver 2.2 gigawatts of domestic manufactured energy storage products.
Okay, and what is Excelsior?
Yeah, so Excelsior is Excelsior Energy Capital, and they have long-term equity investments in North America across renewables, wind, storage, and solar.
Okay, great. So they will own the project, I guess.
Yeah, I believe they will own and operate the project.
Okay, so Fluence makes the products, and it would be great to have some Fluence products on my house, but I think that your products are too big for a house. Is that correct?
That is correct. We do focus on utility scale storage, so it certainly would be overkill, but if you have an event in your area, you could probably, take care of your entire neighborhood. So
Uh-huh.
personally, myself, I'm located in Houston, and we just recently had that hurricane go through. So if I had one in my backyard, I think I would have made everybody in the entire greater neighborhood very, very happy.
Yeah, I was going to ask you too, since you're in Texas and Texas has a unique grid. So, how is the Texas grid different from other grids? And I also know too that the Texas, renewable integration is taken off like crazy, which is pretty cool. And so maybe you can comment on that.
Yeah, so probably not a lot of people know this, but yeah, Texas is one of the largest wind generating grids that we have here in the States, and we got a lot of wind that's coming in. I wouldn't say that the grid is too substantially different. Each grid has sort of its own unique capability. We operate in 47 different markets, and there is some difference between the grids that our system allows us to operate in a multitude of grids. So we do have some systems in Texas that operate on that grid and help support it in times of need.
Great. And so I know that they say the Texas grid is separate from the Eastern and the Western grids in the United States. So it's sort of like Texas is its own country, sort of. I've even had people tell me that you can't connect to the Texas grid from the other grids unless it's a DC connection. And then also you have some of these stories that you hear about where there's like a bad weather, freezing cold, stuff like that. And it's not cold in Texas that much. And so they're kind of unprepared for it. And then you hear about some old lady paying $10,000 for a month's worth of electricity because the kilowatt hour price went up really high. And I know that the solution for things like that is energy storage and building a grid that would be able to handle cold temperatures. So, up north, when you go to colder places, they're just the grids are built for cold weather. And in Texas, not so much so.
Yeah, so in Texas, we have what they call as an unregulated market. So we have a whole bunch of different types of companies. Residents and commercials will get into agreements with them. But the grid itself is operated, my specific grid is operated by ERCOT. And the incident that you're talking about where somebody, spent a lot of money on a per kilowatt hour basis was due to an actual one of those companies that she bought her energy power for. It played fluctuations with the market and felt like that would be a good way to potentially save money, because sometimes you'll even see that the market going price goes negative at some point in time. So it just happened to be that we had an event in which the market price hit its allowable cap, and a lot of those people that were with that provider did get hit with some large bills there.
That's just kind of weird to have it where a utility customer has variable pricing.
Yeah, it's a little weird.
And it might be cool if you had some software and AI and batteries and all that kind of stuff where you can profit from that. But for just your regular customer, that's the old lady that has the $10,000 bill, how is she going to know when to turn stuff off, I guess?
Well, actually, for that particular company, they did send a signal out warning for people to actually jump off their service, because you can move your service in Texas to somebody else, another provider that wouldn't have their pricing structure based on that fluctuation. So they did say do that. And as far as I know, that company is no longer operating in Texas as well. So I'm not aware of any other company that is doing market pricing and bringing it direct to the consumer. But our battery storage systems you can watch them online during certain events. They do engage, and it really does help out with the variability of the solar and the wind penetration that we have into our grid to be able to deliver the power generated from those renewable resources at a time in which they're not being generated, and we need that on our grid to maintain it.
Okay, interesting. All right. And maybe they're not around anymore because that lady didn't pay her bill, you know.
I think some people stepped in and said that this was probably not
Uh-huh.
the best choice to go forward. Yes.
Yeah, and it seems like it would be a good choice if somebody was, connected and tech savvy and all that kind of stuff. But how do you get the signal to somebody that doesn't know how to text message or, stuff like that? And then also, if there's a power outage, maybe you don't get the text message or your phone's dead or you're traveling, or I guess you wouldn't leave the heater on if you're traveling, maybe to keep the pipes from freezing. So the Fluence solution, maybe you could explain, is it more like AC coupled, I guess, DC coupled? How does that work?
Yeah, so we offer a full system package in which we will store in the batteries, and obviously that will be DC, and we use bidirectional inverters that convert AC power into DC to allow it to store inside the batteries. And then when it's called upon by the grid operators that they need additional capacity onto the grid, then they'll send a signal out to the system, and that system will respond, convert it back into AC, and put it onto the grid.
Okay, great. So like when you charge your batteries from solar, you have to convert to AC first, I guess. So that would be AC coupled. And it's like your cubes don't have PV inputs. And so another thing too is I noticed that in an article that I was recently reading about those 2.2 gigawatt hours, which is a ton of batteries, that the factory may have been converting a line that was used for electric vehicles into stationary batteries for Fluence. And so one of the things that usually you'll see is when you're using stationary batteries these days, it's mostly LFP, that's lithium iron phosphate, and that's a type of lithium ion technology. It's a little bit safer, takes a little bit more weight and space to get the same amount of energy. They do make LFP cars, but a lot of cars have some of that cobalt in it. So where NMC is what we see a lot of times with cars. That's lithium, nickel, manganese, cobalt oxide. And so is there any NMC going on with Fluence at all these days, or is it everything LFP?
Right now, we're seeing a vast majority of what we're putting out is LFP, and that mostly is due to the safety concerns around the NMC. The NMC does offer a much more dense energy capacity than LFP does, but with that more dense energy capacity comes with a more volatile chemistry. So we have NMC that we do pursue when the project is right to use NMC, and then we definitely make sure that we put the system protections around that for that more volatile chemistry so we can ensure the safety of it. But also going back to something else that you said, as far as like the solar, we actually offer both capabilities. So we can DC couple a PV array into the system so that it doesn't need to come out as AC from there and then get converted back. But what we're actually seeing a lot of recently is the two assets being separate, that they're not geographically located next to each other. They could be, a couple of miles apart from each other. So of course, in that case, it would be converted to AC, put onto the grid, and then the system would be connected to know how much is coming out of the PV, and then would know how much to go ahead and take off the grid and put into the storage.
Yeah, until a couple of years ago, with the more recent version of the Inflation Reduction Act and the ITC, the investment tax credit, you had to co-locate your solar and your storage to get that 30% tax credit. And now you don't have to do that. And so it makes a lot more sense to put the batteries in all kinds of different places on the grid instead of just where the solar is. And so that just makes a lot of sense for the grid. I think it's better for the grid that way, and probably why you're seeing a lot of AC coupling. So
yeah, certainly. I mean, you want to locate your PV where the sun is going to shine. And then you want to locate your storage where the need is going to be when it arises. So the decoupling of that is really a great thing for our industry and allows us to put the assets where they'll be perform the best.
great. Okay. And so some other things too that I'm sure that a lot of people already know about, but for an energy storage system, you typically need UL 9540, and that's the standard for energy storage systems, the UL standard. And then there's also something called large scale fire testing, which is UL 9540A. And I'm assuming that you go through all those tests.
Yeah, we certainly do. There's actually a sort of standard NFPA 855.
Sure.
And
That's the standard for energy storage systems. Yep.
yep. And so we definitely go through extensive testing and certification to make sure that our systems adhere to that. But at Fluence, safety is one of our core values. And we were one of the first to come up with not just the large scale fire test, but something that we call the beyond fire test, which even takes it a little bit further, that we will actually ignite in an entire enclosure and ensure that it completely will go up into thermal runaway, and that we can prove that it doesn't propagate to the enclosures next to it as well. So it takes it just a little bit further. Additionally, NFPA 855, actually, you can adhere to it on a couple of different ways. You can either adhere to it to NFPA 68, which was, your deflagration testing, in which, if an explosion event would occur, that it is directed in a safe manner. Then you have NFPA 69, in which the active venting will kick in. So if there's a buildup of gases, that an active venting system will actually direct those potential explosive gases out of the enclosure itself. And then the one that you mentioned there was the large scale fire test to see that, to ensure that we don't get the propagation. But that one doesn't necessarily mean that the entire enclosure will go into thermal runaway. So that's why we do the beyond test, which ensures that it will, just so that we can give confidence to our customers and to the first responders if an event would occur, that you're going to be dealing with a mitigated, controlled scenario as much as we can.
So what's the secret for making an energy storage system so safe? Like, do you have water going in there, sprinklers? Do you flood things? Are there different chemicals that get released? And obviously, too, people don't fit inside of these cubes. So you can't go in there and trap yourself inside an enclosed area, which I think people have gone away from. Like in the earlier days, people were using containers and putting batteries in there, and you could go in the container, and that's probably not a good thing.
Yeah, definitely. Yeah, the enclosures that you're seeing now do not allow for any entry into them. So you're always going to be on the outside of them. I've even seen some installations where they're inside of a building. So obviously you would be in the building there. But how we approach safety here at Fluence is really part of our core values. And I asked the team to think about it in about three different aspects of it. From product ideation, can we pick things in which we can guarantee that an event like this would not happen? And that obviously is the utopian type of perspective. And we know that we will never reach that, but we're going to attempt to get there as much as we can. So after we've gone through in our product design and our supplier selection of what we're going to put inside an energy storage unit, then we can move into prevention. So that in itself requires a deep understanding of what you're putting in there. For the LFP, we have a deep understanding of the chemistry and how we could operate the system in a way so that a thermal event would not occur. And how can we notice things at an earlier period of time in which maybe a single bad acting cell in amongst thousands of cells may go into thermal runaway, and we can detect that early and stop operation of that cell or that entire core so that it doesn't happen, and then trigger a response to the service team, whether it's our service team or our customer service team, to go in there and resolve the issue before it actually becomes a thermal event. And then the last bit of what we think about here is mitigation. Assuming that an event like this will occur, what do we have for protections in our system, in our product, that will make sure that it limits the impact of it and will ensure that if the procedure is followed by the first responders and the customers, that we will limit its impact and nobody will be hurt. That is our goal there. So we interact very closely with the customers on safety, and we go through a lot of safety training with the customers. We interact with the AHJs that will respond to any potential event and address their concerns. We have a lot of global coordination and education that we pursue with all of the interested parties. And as I said, inclusive not just with the customer, but also with the local first responders.
So I imagine some of these testing procedures are pretty exciting. And this is, for energy storage systems just in general. They cause thermal runaway. That's part of the test, UL 9540A. And UL 9540A, by the way, is not a listing, it's a test. And so you're pretty much set it on fire. You make it go into thermal runaway, and then you see if it propagates. And have you seen any of these tests, especially on the larger energy storage system, these big cubes? Like these cubes, what's the dimensions of the cube, by the way?
Yeah, it's about 8 feet by 8 feet by 8 feet.
So that's pretty big.
Yeah, so there is a good amount of energy in there. And as we previously discussed, the market is kind of pushing us to have more energy inside a single enclosure. So we are right now actually putting through that same testing of intentionally putting a system into thermal runaway at a larger scale. And so that's why it's going to be critically important for it to be within our entire process, from product ideation to design to manufacturing, that we are addressing those issues as they come up. And I have seen these things go up before. Again, we're intentionally putting them to do into thermal runaway, and it is quite impressive on what happens there, but it is all there to prove that last element of mitigation, that are we safely handling an event if it would to occur. And it would then, again, as I said, we take it a little bit further and we do that beyond burn test. If just putting one module into thermal runaway, we're going to ensure we stress the system, we put a lot of heat into it, and ensure that the entire cube or the entire enclosure for these larger enclosures does go up, and we get the report out for the UL9540A, and that goes into the final certification to try to get the UL9540.
Great. And so you'll put a couple of cubes next to each other for this test, and one of them, you spark it up, you intentionally cause it to catch fire. I think they disable the BMS, the battery management system, and then just overcharge it until something happens, and also can put in heating elements and things like that. And then it doesn't catch the one next to it on fire. How close do these go to each other? Are they just like touching each other?
No, they're not quite touching each other. So the requirement that we follow, both in the large scale and the beyond fire test, is it's supposed to replicate the exact setup that we would have at site. So if we're suggesting that they're 6 inches apart, then we will put the cubes 6 inches apart. There's also some standoffs that you must have for accessibility. So we call it across the row. And we will actually have that enclosure sitting there across the road too as well, so that we can as closely simulate to how it would occur on site if it were to occur. And yes, as you said, the BMS is turned off. So these batteries are fully energized and everything else is turned off, because in an event like this, you can't expect that you're going to have a powered system. So this, again, you've gone past prevention. We had a lot of prevention capabilities that we could monitor this ahead of time, electrically isolate the enclosure. Now we're in mitigation, that we forced it into this event and we need to make sure that it doesn't propagate to the next enclosure. So we have a lot of temperature sensors, a lot of gas sampling sensors to understand what is coming off of these enclosures. And we watch that temperature rise on those close next to it cubes or enclosures. And if it rises above a certain temperature, then we know that we got to create more space between those two enclosures. So it really is about that temperature. In your initial design, did you create it in a way that would allow you to bring in the enclosures closer together and ensure that you don't get that propagation? If you don't have that, then you do need to create larger distances between your enclosures, which, as we talked about earlier, with the square footage of the site's availability for land, that's going to hurt you in the long run. You won't have good site density.
Great. So you're beyond fire test. And so that would mean going beyond the minimum requirements like UL9540A, large scale fire testing, things like that. So what aspects are you going beyond?
So we ensure that the entire enclosure will actually go into thermal runaway, and that it has as much oxygen as it possibly could get in order to make that thermal event to continue to go forward. And in doing so, we say that this is absolutely the worst case that could occur with a single enclosure. And even though we put it underneath that condition, it still does not propagate.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. Okay, great. So your title at Fluence is Vice President of Product and Program Management. And so what does that entail? Like product and program management?
So, like any other product manager, we have the responsibilities of understanding the needs of our customers, understanding the needs of our markets. And then at Fluence, we get to enjoy a global market here. And then working on developing products that will meet those market needs and place Fluence in a very competitive stance in those markets. The program management side of what I do here at Fluence is leading those development efforts within our R&D department. So we manage the actual process of execution of developing those products. So it's really exciting that I get the opportunity to not just determine what we should make, but I'm heavily involved in the actual making of it and the product launching.
Great. Awesome. And so you are in Texas, and I did read something about like working with the oil and gas industry. Do you do a lot of that? How's the relationship with people that are in industries that are not necessarily into renewables? Like I know you can even help the grid, whether it's a renewable grid or not.
Yeah, that's exactly right. And that's where storage is really coming into play in the market is that with the large penetration of renewables into the grid, it's created somewhat of a destabilization in the grid because of its sporadic capabilities to generate. So, when the sun shines, that's when you're going to generate energy from the PV. When the wind blows, that's where you're going to create it from your wind turbines. So, what do we do if we don't need that energy at the time in which it's being generated? So, we store that energy and then we deploy it out when those assets are not generating energy, but the grid does need it. So, it actually will help the health of the overall grid to kind of levelize it out. And we call that energy shifting. And so, you probably are very familiar in your podcast here of the duck curve. So, we try to reduce the impact of that duck curve and put the energy when it's needed, where it's needed.
Yeah, maybe just since you said the duck curve for anybody that isn't familiar with that, it's a curve that looks sort of like a duck. And so the middle of the day when there's a whole lot of solar energy out there, that's sort of the back of the duck. And then as the sun sets and people come home from work, there's less energy available, and that's the head of the duck. And so we need to shift the energy from the daytime when people aren't home, and then they bring it over there and take off the head of the duck. And then at lunchtime, you just eat the duck.
That's a good way of describing it. Yes. Without the penetration of the renewables, we didn't really have this before. The traditional fossil fuel spinning turbines were generating a levelized amount of energy and people would use it and it would always be available there. But with that penetration and the driving on less reliance of those fossil fuel energy generation, we are experiencing this.
Fossil fuels are energy storage. It's just that sun hasn't been up for, since the dinosaurs were around. So,
Well, it is dinosaurs, right?
yep. Yep. Some of it is. I wonder what percentage, some fraction of a percent is some decomposed T-Rex.
An interesting aspect that we're seeing in other markets really starting to play into the importance of storage is that we can actually help stabilize the grid when events occur. So if you see frequency starting to get off, you start to see voltage fluctuations through advanced applications and the way that we deploy the energy, we can actually respond and help stabilize the grid. So in a way, we can actually act like a spinning asset and even deliver inertia into the grid in order to help keep it stable. So we definitely have a lot of capabilities that we can do with energy storage. It is energy and we're delivering it into the grid and supporting that renewable penetration while we still have those spinning assets that we've relied on before.
So there's different types of inverters too that can do different things. And so pretty much your regular interactive inverter that most people are familiar with is called a grid following inverter. So it follows what the grid is doing and it turns off if it's out of spec. And as more and more renewables get on the grid that are intermittent, we're starting to have a need for what's called a grid forming inverter. And so is Fluence working with the grid forming technology yet, or is it just too early? I know that there's a lot of people also in Texas that are like working on developing these grid forming technologies. And in places where there's a lot more intermittent renewables like Australia, there's more grid forming inverters starting to pop up. It's still, I believe, in the real early days.
Yeah, you're right. It is starting to pop up. It is in the early days, but we're definitely in those discussions and integrating in those grid forming inverters into our product. Australia, as you mentioned, is one of those markets that's at the forefront of it. And it's pretty much a requirement if you're going to be putting a storage asset in Australia that you do offer grid forming capabilities. So it's here. And Fluence is looking at bringing that to the market as quickly as possible.
Yeah, and even if you had one in a lot of places in the United States, if you had a grid forming inverter, you might not be able to use the grid forming technologies just because the grid code or the rules for the grid aren't ready for that yet. because you're going to be out there stabilizing the grid. So if you look at like fossil fuel power plants and nuclear power plants, they do have a lot of this like inertia, and they're forming the grid pretty much. And then we were just this little percentage of the grid, and we're inverter-based resources. They call them IBRs, and they don't have that same type of reaction to when there's a problem with the grid. And so it's just some real neat technology that we're starting to see. And so that's good to know that if somebody in Australia wants to buy an inverter with grid forming functions, you can sell them that, I guess.
Yeah, we definitely can. And in fact, Fluence was one of the first to bring to market something that we call Ultrastack, which is for the TSO market. And we're seeing a couple of applications in projects that we're moving forward with in the EMEA market. So the transmission system operator that is responsible for making sure that the grid is stabilized and is healthy. We got a couple of projects that we're implementing our Ultrastack product. That is really where it's fast response, a lot of energy being able to be deployed when it's necessary in order to stabilize that grid, and a lot of advanced applications that go on top of these specialized inverters that are starting to come out.
Great, awesome. Yeah, and I was just thinking of another way to describe it too, is you have anti-islanding. And so all of these inverters, they're interactive inverters, they're on the grid. And so when the grid goes down, they turn off. Well, what happens if the whole grid is all these inverters that do anti-islanding? Then there's nothing to keep the grid on. And so these grid forming inverters have characteristics that are perhaps sort of like standalone inverters, and like an off-grid inverter that can keep the grid going. And there needs to be a certain percentage of that to have a robust and resilient grid that can handle the little hiccups and things like that. So anyway, there's a lot to that. Yep.
Yeah, I mean, even beyond just being able to help out with those little hiccups and keep the grid stable, if the grid does actually completely go down, it's really difficult to bring those spinning generators back up. So our product with a grid forming capability can actually help support bringing those assets back up quicker than they were before. So if you do have an event in which brings down the entire grid, we're there to help support bringing it up much earlier than possible.
So they call that black start.
That's correct.
When the grid's totally off and you need to just give it a little kickstart. And traditionally, they have to keep diesel generators sitting there that are never, barely ever used, except just to, sort of like a starter motor for the grid. And now you have these energy storage assets there where if you have the right ways to control them, then they can do that themselves. And you don't need to waste your money on having all these diesel generators sitting there that are just waiting for some kind of a problem that hopefully never happens. A lot of neat stuff going on out there. So maybe we can go back a little bit to like manufacturing and the Inflation Reduction Act. And is Fluence manufacturing or buying from other manufacturers for the most part?
Both, actually. So, in areas where we felt like we had a much better core competency than what we were seeing out there, we've taken the manufacturing in house. So, we have in our manufacturing facility in Utah, we're able to manufacture a module in which all the cells will go into that. And so we're actually going through that safety testing that we were talking about. Like it just doesn't start with the enclosure. There's actually UL 9540A that goes test procedures that go all the way back to an individual cell. So we're working on getting that test completed on our own manufactured module, but we don't yet have that cell manufacturing. So we still rely on partners in order to manufacture the cells. And due to the IRA, we're starting to see an uptick and a lot of interest of those cell manufacturing companies coming to the United States. So that's really exciting. We've partnered with one of them to bring the manufacturing here to the US. And then, like I said, we're taking their cells, putting it within our own manufactured module, and then putting that inside our own manufactured and designed enclosures.
So there's three primary types of cells out there. There's the cylindrical that looks sort of like your battery that people are used to sticking in their flashlight. There is a pouch battery. If you ever seen them replace the battery in your phone, it's just kind of flat. And if you rolled it up, it would be cylindrical. And then there's something called the prismatic battery, and they just sort of roll it up, but it's sort of like flat, but it's round around the edges, and then they put it inside of a case. So are you using all the technologies or one in particular?
We're seeing a lot of the cell manufacturers that are supplying for the large scale energy storage going to the prismatic cell. And that roll up that you were talking about there is actually, I guess, called a jelly roll.
Yeah, jelly roll. Yeah. We have to go to a donut shop to explain that.
Yeah.
Yeah.
I actually recently visited one of our cell suppliers and saw their entire manufacturing process. It's a really interesting process that goes through from creating the cathode, the anode, putting those two together with the separator, and then putting them into a big roll that they will squish down and then put a couple of those into that square or rectangle box that we take for the prismatic cell. So that's mostly where we're at, but we're also working very closely with those cell manufacturers. I think that they're going to start trying to bring over some technologies that they've developed for the automotive industry. And we're looking at potentially going away from the jelly roll, still in the prismatic cell form factor, but going to a stack where instead of rolling it, they will cut the combination of the anode and cathode into strips and then stack those strips on top of each other. And we're starting to see a lot of benefit in the potential energy density that would be able to be contained within those types of cells.
Great. So just at those prismatic cells, do you know how many amp hours or watt hours they are?
Yeah, they're varying and they're getting much, much bigger. A lot of the market grew on a 280 amp hour module that is a collection of 52 of those cells put together. And now we're seeing that that's becoming much, much bigger. So we're looking at 3xx amp hour modules created by those cells, and we're getting into a much longer module form factor. So where we're putting in not just 52 of those cells, we're putting in 104 of those cells into a longer module. And we're starting to see that the cell companies are looking at 5XX, potentially 6XX that will be coming out in 26, 27.
So when you say 5 or 6 XX, that means 5 or 6 times as big of a battery?
No, so I apologize using some of our terminology here,
Mm.
but it's anything within the 500 to 600 range is what we call 5XX. Companies are coming out with 530 or 580 amp hour
Amp
cells.
hours. So let's see, if I just take 600 amp hours and then I multiply that times 3.2 volts, that's the nominal voltage for an LFP battery, lithium iron phosphate, and I get 1.9 kilowatt hours for a single battery cell. That's pretty big.
Pretty big. There's a lot of energy density in these things. And again, it goes back to the critical reason why we got to focus on safety here, because the industry is definitely pushing to more energy capacity and a smaller form factor.
And so how many of these did you say you would put inside of a module?
Inside of a module, we're starting to see about 104 of those cells. We call that a long module, whereas before we were doing 52 and it's a short. So you could think of as you've seen the standard shipping containers. A long
Wow.
module will run that depth distance of about 8 feet in there. These are big modules. That's why you won't see them at your house.
That's like, I did the math, and that's just about 200 kilowatt hours. So that is pretty big. And so to put that into perspective, just like the car with the most kilowatt hours is probably around 100 kilowatt hours. I'm sure there's probably one greater than that, but I know there's some Tesla Model S's going around that are 100 kilowatt hours. And so that's like taking two of those in just a single module. And so let's even say like a module is something that you put a whole bunch of batteries together in, and then sort of like a solar module is a whole bunch of solar cells, and an energy storage module would be a whole bunch of battery cells. You put it into this module, and then you can put it in, take it out, and replace it, and things like that.
Yeah, exactly. I mean, the module itself is a complete contained unit. I mean, they get a very high IP rating on this. You could dunk it underwater if you wanted to.
Let's go swimming.
But then we also take a collection of those modules and put it inside an enclosure. So as we're seeing those enclosure sizes getting bigger to more of a standard 20-foot ISO container, you're looking at one single enclosure would be able to have, 5 to 6, even in some cases, we're looking at, getting into the 7 MWh.
Wow, 7 MWh. That's pretty big. And so what would happen if you had one of these 200 kilowatt hour modules and just one single cell goes bad, does it just have some way where you can just automatically bypass it, or do you need to go and pull out that module?
The module itself at that point would have to be replaced. And that's typically what is happening. It's not an entire module that is going bad. It is one bad actor cell out of all of them that is an issue. So it's critical for companies like us at Fluence to be able to monitor those cells individually with our battery management system, or BMS, that we are constantly monitoring the voltage and the temperature of those individual cells and being able to understand, is this one a problem cell? So we get down to, with a large amount of data that we're pulling off of these systems with our BMS, is combing through that and creating a specific fingerprint for each one of those cells so that we know how it acts. And then we can watch that through some AI and machine learning capabilities of when it would deviate from its normal behavior. And when we start to see that deviation, that's where the prevention aspect of what I mentioned before comes into play, that we immediately alert, we will isolate that. And, it depends on the system that you have it set up. Do you isolate it down to just the module? That would probably, at this point in time, that's really the lowest that you can go. Or do we go even further and just isolate the enclosure or the entire core that goes up to a single inverter on a system? So it depends on how you build your system out, and there's varying justification for getting more granular or not. So we're working on providing those products to allow that variability for our customers.
Okay, wow. So that sounds like one bad cell, and then you have to take out this huge module. That sounds like a lot of work. And then I'm sure that you don't throw that module away, you just replace the cell somehow. Is that something that would be done on site?
No, we would actually take that module and send it back to where it was manufactured at and see if there is anything else that we can do with those parts. Are the rest of the cells fine? You may want to use them, but at some point in time, you've actually used these cells and they've degraded. So typically what we will do is we will remove the bad module that has the bad acting cell in it and then replace it with a new one.
Yeah, I think what they do for a lot of electric vehicles, when there's a bad cell or group of cells, something like that, is they will take out the batteries and then they'll test the individual batteries, and then they'll use some used ones to top off the other batteries that are just missing a cell, something like that. I remember they even did that with my old Toyota Prius, version 1. The first time I had to replace the hybrid battery, I went to this guy and he just jumped in the back of my car and he pulled out my battery. You could see that he'd done it hundreds of times. And then he said he would go to junkyards, find old Prius batteries, and then he would load test the individual cells. And he replaced bad cells with good cells that he just load tested. And that battery actually lasted as long as the original, even though it was used battery. So I thought that was kind of cool. And I think that's what they'll do too when my electric vehicle has a battery problem, is they'll take my battery and then use that as like a bank of batteries, for replacements and things like that. So anyway.
Yeah, no, that's exactly how that works. I myself have a Prius in my family, and I'm starting to see a little bit of the signals. There's only a certain amount of life that those batteries that they put into those cars last. And I think I'm almost getting close to what you experienced there. But you can't necessarily put a brand new cell amongst all the other cells that are fine inside that module. You have to find one that is basically going to be in line with the rest of them as well, so that you can charge and discharge that up as a single unit.
Yeah, and mine was a 2002 Prius. And I remember when I bought it, I said, my next car is going to be electric. Nobody believed me, and I was right. And so then I was looking around on YouTube videos on, people replacing individual cells. And I was like, should I do this? I don't have time, I'm busy. And then one time I was riding my bike by a Prius that was like mine, and it had no back seat in it. And you could see that somebody just had the battery sitting there replacing cells. And so I thought that was kind of interesting or dangerous or both. Driving around, bouncing around with all these, that they were nickel metal hydride battery cells on the older Priuses. So that they weren't even up to the lithium ion batteries yet. So let's see, is there anything else that you want to cover?
think we talked a lot about the safety. And I mean, we talked about kind of future with the larger enclosure sizes, the greater cells coming out.
So for that, for like the future, how far away in the future is that? Are you still primarily using the cube shape, or have you gone up to the cuboid, to the more, rectangular type of cube?
Yeah, so a few months back, we actually announced the GridStack Pro product line. And
Mhm.
that product line got three different enclosure sizes in its product, where we have the 20-foot ISO container size, then we have another 20-footer, but it's not quite as deep. We allow for short modules in there. That mostly going to be our domestic content for the Americas region. That's those modules coming off of that production line that I mentioned earlier. And then a smaller, more closer to the form factor of the cube that can be seen today. And the reason for the multitude of sizes is because there's not a one product fits all aspect to this. Based on where you're going to be, you may not be able to deliver a very heavy 20-foot enclosure. We're getting close to limitations on logistics to be able to not just put this on a ship and bring it over to where it is, but the restrictions on the road for the tonnage that you can have to deliver it. And if you want to put something on the side of a mountain, it's probably not that great to try to do a 20-footer. So we have the smaller form factors that you can bring and put there, but also it helps with energy balancing as well. So you could create a DC block behind it that closely matches what the inverters out there in the market are available to take, so that you're not overpaying for the inverter, or you're not putting too much battery capacity behind the inverter. You can really right size that to allow for the cost effective solution.
Great. Well, I think the Cube is the coolest looking energy storage system out there. So I hope you guys keep some form of the Cube. That's just my personal opinion. But I guess it's 8 feet on a side for a cube. And that's probably because 8 feet is as much as you can fit on the roads. Is that?
No, so we built the enclosure around the module sizes that we had at
Mm.
the time. So we call them short modules today. That's where you would only have 52 of those cells inside a single module. And so, we were able to fit a module into the depth of that. We need to keep these enclosures conditioned so that they don't overheat or they don't get too cold. So we have like a heater and HVAC system inside these enclosures. We also have a chiller because these are all like liquid cooled with a cold plate within the module to make sure that we manage the temperature as during charge and discharge. So there's a lot of equipment inside that, and really the form factor is defined by that module. And so that's why you're going to see them get bigger now, because the industry is moving to a longer module.
Great. Okay. Well, thank you so much for all of this great information. And I hope everybody out there goes out and picks up a few cubes. We got to figure out how to put them on our houses, though. But how many kilowatt hours will fit into a cube?
And to those cubes, it's about 750.
That's exactly what I need for my backyard. That would be like seasonal storage for a house, perhaps.
Exactly. Yeah. Then you won't have to run that diesel generator that turns on in the back of your house. You get that.
Oh, yeah. Don't tell anybody about my big diesel generator in the backyard. That's a secret. And so for the cubes too, you don't stack them on top of each other, right? They just go next to each other.
Yeah, they just go next to each other.
Mm.
The panels on the top are critical. They got to open up in order to direct any potential fire or gases up and away from anybody that may be close to the enclosure. So we don't put them on top of each other so that we can ensure that safety.
Okay. Oh, there was one more thing I wanted to ask you about too. And it's what everybody's talking about these days: AI, artificial intelligence, and VPPs, virtual power plants. And also, I see that on the Fluence website, it talks about AI bidding software, Mosaic. So, do you have any comments about that? How does that work?
Yeah, so we got two digital products that we offer into the market. One is our Nispera, and that really is that collection of that enormous amount of data coming off, and it allows you to manage and maintain the asset. And it's really the what's watching what's going on there. Then, as you mentioned, we have Mosaic, which is our bidding software, and we have that software in a multitude of markets that will allow you to bid into it. And so what it's doing there is watching when it would be best to buy and when it would be best to sell the energy that's being stored within the battery system to help our customers make a return on their investment.
Great. So that old lady that had the $10,000 electric bill, she should have had some of this software.
Or ERCOT should, have more of our assets on there. So, they wouldn't be buying it themselves, but, our customers can certainly buy these systems and leverage our Mosaic software in order to put them onto the ERCOT grid so that that old lady doesn't have that event ever happen again.
Great. Well, thank you so much. So how can people find you, get a hold of you, buy some longer cubes?
So we operate in three main regions: Americas, EMEA, and the APAC region. And we have great sales teams that focus on each of those regions. So depending upon where you're at in the world, reach out via of our website and get in touch with the sales people and what we also call our sales engineers that will walk you through the journey of planning, installing, and then operating.
Great. Okay, thanks. And then I know that you are on LinkedIn. So your last name is Berger, Mark Berger, Mark with a K at the end. And it was pretty easy to find you there. And what's the Fluence website?
It's just fluenceenergy.com.
And that's Fluence. Great.
Yeah, don't forget the double E there.
Oh yeah, double E, because Fluence ends with an E and energy still starts with an E. So great. Thanks so much, Mark Berger, for being on Shawn White's Solar and Energy Storage Podcast. To find out more about solar, about energy storage, to get your NABCEP ESIP, that's Energy Storage Installation Professional Certification, just look me up. Go to Solar, SEAN, that's solarshawn.com. Cool. Thanks so much, Mark.